Bismillahirrahmanirrahim, and welcome to another lecture of CS101. This week we'll start by looking at what are storage classes. If you recall, in the previous lecture we discussed about passing parameters to functions, and we saw that there were two types of the two different ways that we can pass a parameter to a function. The first one was passing by value, in which the copy or of the value of the parameter being passed is copied to in the function, and the second one was passing by reference, in which only an alias is being created, and in fact the variable in the function is also referring to the same variable from where we are passing. In that case it was the main function. So just to have a recall, let me write two functions over here. So let's have int and function number one. Let's suppose it has int x, and I am going to write return plus plus x, and another function int, so function 2. This has int, in this case I am passing a reference, so, and this has return plus plus x. So they both do the same thing, but in this case we are just passing this is, let me write it here, int x. So this is taking the value, this is taking by value, and this is taking by reference. So let's see what's the difference between them. Just to recall, we have studied it already in the last lecture. So let's try int and main. So here I have int x is equal to, let's say, 5, and let me try see out, and let's see out function 1 with x, and then see out x again to see whether the value has changed or not, and then call the second function. So we have see out function 2, again I'm passing x, and then again see out the original x to see whether the value has changed or not, and then return 0 and exit the main function. So let's see what happens. Here we have int x is equal to 5. So once I call this function function 1 with the value x, so basically what I'm doing is I'm passing the value 5 to this function. So this x here, this x now becomes equal to 5, and when I do plus plus x, so this becomes 6, and I return. So what will be returned? It's plus plus, it's a pre-increment, so the value returned over here will be 6. So when I write see out function x, it will return the value 6. So what's going to be output here? 6. This x remains the same. This is 5 because the value 5 was copied over here. So nothing will happen to this original x. So when I see out x again, this will be 5. So this shows that the value in the function is increment, has an increment, but the original value 5 does not change. So we have 6 and 5 respectively. In the second case, so this is when I did passing by value. If I do passing by reference, so this is by reference. When I do the passing by reference, if I write see out function 2, again I pass x. X was 5. So here it doesn't really get the value 5, it gets a reference to this original variable x. So this variable here is 5. When I do plus plus x, this becomes 6, but so does this. This also becomes 6. because they're pointing to the same location, and the reason being that this is passing by reference and not passing by value. So when I write cout function 2 x, this is going to, what's going to return? It's going to return 6. So this is going to be 6, is the same as the previous one. So this, they're doing the same thing, returning plus plus x. So it doesn't matter, you get the same value, 6 and 6. What has changed, however, is that in this case the original value x was still 5, but now the original value x has become 6. So when you write a cout over here, you are going to get 6, and that is the difference between passing by value and passing by reference. So let's move on to today's topic, and we can see that in this case we passed variables, for instance x, but if we want, we can also write a function that does not has any variable. So you can do that in two ways. You either leave it blank. So if you want to print something, you are making a function to print something, you can write the function name print with open bracket, close bracket. You can leave it blank. It means that this function print does not take any parameter. Or you can explicitly write void. It means you're emphasizing on the fact that this does not take any parameter. And when you write void, it means that you're explicitly telling it that it cannot take any argument, any parameter. If you leave it, it means you just didn't pass any parameter over here. So the function print takes no argument and returns no value. No value because this is void. Void means it does not return any value. So here's an example. We have void function 1 and void function 2 with void. You can write it both ways. Either you leave it empty or you write a void. And those functions are basically, you can see there is no return type over here. So these are voids as well. It doesn't take any parameter. It just makes a cout statement. Function 1 takes no argument and function 2 also takes no argument. So you can call it function 1 and function 2. When you're calling it, they look exactly the same. And they're doing exactly the same function as well. So this is just a tip, because we'll be using some of this syntax in today's lecture. So another thing that you can we'll also be looking at is that you can also have default arguments or default values for the parameters that you are passing. So if a function parameter is omitted, it gets the default value. So int default function, you can write anything. If you have int x is equal to 1, y equal to 2, and z equal to 3. So what this means is that when you call the function, if you are supplying the arguments, they will be replaced. However, if you are not supplying, then these values will be used. So for instance, here's an example. We have the function called a box volume. So we are trying to calculate the volume of a box. We have the length 1, width 1, and height 1. So in the main function, if you write the default box volume is, just write box volume, and there is no input parameters, even though this function has 3 inputs. So length, width, and height, they are supposed to be 3 inputs, but you can see that we are calling this function without any arguments being passed. So since nothing is being passed, it means that it's going to use the default values, length equal to 1, width equal to 1, and height equal to 1. If I want, I can just pass one value. If I write box volume of 10, it means now that the length of the first one is going to be replaced by 10. And the other two will still be 1 and 1. If I write 10 and 5, it means the length will be 10, width will be 5, and because there is no value for the height, it will be 1, which is the default value. And if I call this function with 3 values, then all the variables, all the parameters will have the new values. So in this case, length will be 10, width will be 5, and height will be 2. So, and this is the function itself, this is the function prototype, and this is the function itself, and you can see that the only thing it does is return length into width into height. So depending on which type of or which version or which variation, not a version but which variation of the function you are calling, whether it is with parameters, with no parameters, with some parameters, all with all parameters, some of the default values may or may not be used. So in this case, so if you have the first one, in this case, since you are passing no parameter, it means that all the values being used is 1, 1 and 1. So I'm using this as a comment to denote what will be the output. So the output doesn't mean I'm putting a comment here, because this is a continuous cout statement. You cannot put a comment over here. This is just for the slides. It's not supposed to be in the code, this comment. So 1, 1 and 1. So the answer here, the volume will be 1 in this case. For this one, let me, instead of use the arrow. In this case, we have the length to be 10, the width is 1, and the height is 1, because only one parameter is being supplied. So this will be 10 by 1. So this is going to be 10 into 1 into 1, which is equal to 10. And in this case, we will have, so the length and the width is being supplied. So we have 10 into 5 into 1, which is 50, and in this case we have 10 into 5 into 2, which is 100. So you can see that we have only one function, and depending on whether we supply the parameters or not, you can have different answers. Right, so let's move on to the main topic for today. So this we just saw that you can have a function with no arguments, no parameters being passed. Either you leave it empty or you put a void in there. That's the first thing. And the second thing is that if you want, you can supply default arguments, and the default values will be used if no new arguments are being supplied at the time of calling the function. If you do supply the new values, then the new values will be used. If you don't, then the default values will be used. And you can supply no values for the parameters when calling. You can input some value, or you can input all the values, just as we saw in the last example. Anyway, coming to today's topic, so we're going to talk about the storage classes. So this is an interesting concept. Some of the storage classes we have already been using, but we didn't give them a name, but we have been using them. So there is going to be one new storage class that we'll see that we have not been previously using. The other two types, there are in fact 5 storage classes. We'll see that 3 of them are important. We'll just skip 1 or 2 of them because they are not used in this course. You may use them in an advanced course. And in the 3, we have already used 2, and so we have to study just one new storage class. So what are the attributes of a variable? When you define a variable, for instance, you write int a variable or x is equal to 5. There are many things that you are describing. The first one is the type. So integer is a type of variable. The type is int. The name is var, var. The size is going to be the size of integer, and the value here is going to be 5. So these are the 4 things that you have supplied to the compiler, to the software that is running this program. When you write int variable, it could have been I equal to 5 or x equal to 5 or anything. So what is an identifier? An identifier is used for any variable, function or data definition. And each identifier in a program has other attributes. So these are some of the attributes, but they have other attributes as well. One of them is called the storage class. The second one is called the scope, and the third one, which we will not look at here, is called the linkage. So we will skip this. We'll skip this part and we'll look at these 2 parts. So the storage class means that for how long a variable will exist. Is it going to exist for the duration of the whole program? Is it repeatedly created and destroyed, or does it only exist briefly? So for how long a variable, for instance this variable var, how long does it exist? And there are, as I said, there are 5 different types: the auto, the register, the extern, the mutable, and static. So normal variables that we have defined so far inside the scope of main, they are auto variables. They are auto variables, variables inside a loop, variables inside a function. All the variables that we have been using, they are auto variables. The extern variable is something that we use only sometimes. This is called a global variable. It's a variable that is defined outside of main. It is accessible everywhere. Mutable, we are not going to look into it. So extern is a global variable. Now this is the normal variable that you are used to. So the normal variable that you are used to, this is the auto variable. The extern is a global variable. Mutable we are not going to look at. Register is basically telling you where the variable is going to be stored, either in the RAM or the register. So the storage class that is of importance to us now here is the static, which we have not seen and which we are going to look at today. So this you have been using before. This you may or you may not have used. This you may or may not have used. This we are not going to study, and this just simply tells us whether you are going to store the variable in the register or in the RAM. So out of 5 now we know that we have already seen 2 before, and then we just need to study the third one. So the auto variable, the automatic variable, is an object is created and destroyed within its block. If you recall, I have been saying in many classes that a variable is either created, its scope is limited to its block. A block is the starting of a bracket and the ending of a bracket. It can also only be used with local variables and parameters. And there are 2, the auto and the register. The auto is the normal one we have used. So actually when you write int x is equal to 2, there is an auto here. We just don't write it because this is the default value. If you don't write anything, you write int x is equal to 2, by default it is an auto variable. It means that, you know, if you write it inside this block, it will exist for the duration of this block, and its scope is also limited to this block. You can't access x over here, and you can't access x over here. It is limited to the block in which it is defined. The register, as I said, it is something that you can try to put in a high speed register. So register is something that is very close to CPU. They are faster than RAM, and you can try and you can write register int counter equal to 1. So basically the name of the variable is counter, the value is 1, the type is int, the size is the size of integer, and this just saying that if possible try to make this variable in the register rather than the RAM. That's only what this is trying to say. And you cannot use 2 auto register, that is not possible, because this is a conflict. Either it has to be auto or register. So anyway, this register is not that important. The auto is important, but it is the variable that you have been using throughout this course. The important one is the static storage, as I said. So static storage means that a variable is it may or may not be a local variable, but it is going to keep its value even when the function ends. The scope is the same as the scope of a function. Usually we use the static variable inside a function, and what it means if we define a variable as static is that the value of the variable will not be destroyed when the function ends. Normally when a function starts, the variable is defined. When the function ends, the variable is destroyed. If we define it as static, then it will not be destroyed. It will be there the next time we call the variable. The same value will be there. Right. Externs are global variables, and they are known to any function. We'll look at it briefly. And mutable, we are not going to look at it because it's something to do with classes. We're not studying classes in this course. So the next thing we need to consider is the scope of the variable. The scope means where the variable is visible. You can have the file scope, the function scope, the block scope, or the prototype scope. So as I said, a scope is when you start the brackets and end a bracket. So if I have, for instance, int main and I have int x is equal to 2, this is an auto variable. It starts when this function starts, it will end when the function ends. Its file is a function or scope. It means that it is visible in the entire main function, and as soon as the function exits, the value will also exit. But you cannot, if you have int function over here, you cannot access, so cannot access x. Why? Because x is only inside main, it is not inside this function. So you cannot access x over here unless you define a new one or you pass it by reference. But even then you are accessing this variable, you're not making a new variable. So if I write a loop over here for int I equal to 0, I is less than 5, I plus plus, again I write int x is equal to let's say 5. You see, you have an x over here and then you have another x over here. This is again limited to the block. So this x has a function scope where the function is the main function. This x over here has a block scope because it's visible within this block only. If I try to write cout x here, I am accessing this variable and not this one, because this variable has only access within the block, and then return 0 and so on. So we'll look at these one by one. I think it will be more clear when we look at a few examples. So let's look at this example. Here we have three functions a, b and c. Now you know why we studied void, because they are being used over here. So void a, void, it means a is a function, doesn't take a parameter, doesn't return a parameter. B is another function, doesn't take a parameter, doesn't return a parameter, and so is e. Here's a new thing, int x is equal to 1. This is a global variable. If you recall, we had this extern. This is the global variable. It is visible, its duration is for the entire program. It is visible in any function, whether the main function or any of the other function. So एक global variable जो है वो पूरे प्रोग्राम के लिए होता है और हर जगह विजिबल होता है, चाहे वो मेन में हो चाहे वो किसी और फंक्शन में हो. That is the extern and that is the global variable. Int x is equal to 5. This is a local variable. The scope is that of this main function. This x over here, int x equal to 7, this is a new variable, a new local variable. Both this and this are auto variables. This is a variable x whose scope, the scope of this is the function main, the scope of this is just the block. So ये जो ब्लॉक स्टार्ट हुआ यहाँ से और यहाँ तक, सिर्फ इसके अंदर जो है वो विजिबल है ये x, and this x is visible anywhere. So this x is visible in main, it is visible in function a, function b and function c. It's visible everywhere. This is a global variable, its storage class is extern. This here is a local variable, its storage class is auto. Inside of A and B, we'll try to have a static variable as well, just to show you what the static variable does. So यहाँ पे मेरे पास we have x is equal to 5. So this is a local variable. If we see out a local variable x is outer scope of main is local x in outer scope of main is x. So what should be the output over here? The output over here should be 5, because this is what we are trying to access. Here we have another cout, local x in inner scope of main. So here I am inside the scope of this block. The value here should be this one, 7. If there was no x over here, then I would have used this value, x is equal to 5. If there was no 5, I would have used x equal to 1. So in terms of memory, this is how they look like. This is x is equal to 1. This is the global variable. Then we have the main. Inside the main, so here we have the main. Inside the main, x is equal to 5. And then we have the block. And this is the block. And inside the block, x is equal to 7. So where is this cout statement? This cout statement is inside main. Therefore, this variable is being accessed. This cout statement is inside the block. Therefore, this x is being accessed. If this did not exist, it means that the block would automatically take the value 5. If x did not exist in the main, it means both the block and the main would have taken the value 1. So this is going to give you 5, this is going to give you 7. So even though we have a new x is equal to 7, it starts here and ends here. Outside of this, we have x. Again, we are trying to output x. So this is inside the main and outside of the block. So inside the main, outside of the block, this is the variable that's being accessed. So this also is going to be 5. Now this is going to be the interesting part. We are calling the functions a, b, c, and then a, b, c. Let's look at what the functions are doing. So here are the 3 functions. So the first function a has x equal to 25, and it prints the value, increments it, and then prints it again. So when we combine the entire program, let's just remember that each of the function does something. This has a simple auto variable x, whose scope is the function scope, and the function here is a. What the function is doing is it prints the value before, increments it, and then prints it after. So all these functions are doing the same thing in the sense that they are printing the value before, doing some increment, and then the variable after as well. So here x equal to 25, it's a local variable defined inside a. Inside b, we have another local variable x, but in this case it is static. It means that this x will be initialized only once, not every time b is called. Only on the first call of b we will have an x. And this c does not have the variable x, but still using x. It means the global variable x is being used over here, since there is no x being defined here. This has an x, this has an x, this does not have an x. Therefore, the global variable x is being used over here. So let's look at what happens. I think I have the program together. Yes. So recall that each of the function had the variable x, writes the value, increments it, and then writes a new value. So what does the function a does? A had the function A, it had int x equal to 25, right? And what it does, it is plus plus x. It c out over here does a plus plus, then c outs again. The function b, what does it do? Let's look. It has a static int x equal to 50, does the same thing. So in this case we have static x is equal to 50, static int x is equal to 50 बेसिकली. और ये भी प्लस प्लस एक्स ही कर रहा है, यहाँ पे सी आउट करता है, प्लस प्लस करता है, फिर सी आउट करता है. जबकि सी जो है वो उसके पास एक्स नहीं है, एक्स इज इक्वल टू एक्स इंटू 10 करता है. सो इन सी देर इज नो एक्स, द ओनली थिंग इज इट डज इज एक्स static equal to 10. It C outs here and C outs here. So with that let's see. ये तो हमने देख लिया. यहाँ पे ये वाला कौन सा यूज़ करेगा, ये वैल्यू करेगा 5. We looked at it. ये ब्लॉक के अंदर है, ये हमारे पास होगा 7. ये ब्लॉक के बाहर है लेकिन मेन के अंदर है, ये भी हमारे पास करेगा 5. Now let's see. When we call a, the function a variable x is created, the value is 25, it is c out, it is incremented and then c out again. So when a is called, a new variable called x is created whose value is 25 and then you see out that x25. So पहला काम तो ये क्या करेगा, यहाँ पे x जो है वो 25 सी आउट करेगा, उसके बाद प्लस प्लस x, उसके बाद फिर सी आउट करेगा. प्लस प्लस एक्स करने के बाद जब सी आउट करेगा तो ये क्या हो जाएगी, 26 हो जाएगी वैल्यू. उसके बाद फंक्शन ख़त्म होता है. फंक्शन ख़त्म होने का मतलब ये है कि द वेरिएबल एक्स इज़ डिस्ट्रॉयड, एक्स डज नॉट एग्जिस्ट एनी मोर. जैसे ही फंक्शन ख़त्म हुआ, एक्स वेरिएबल क्योंकि लोकल था इस फंक्शन में, द वेरिएबल गेट्स डिस्ट्रॉयड. लेट्स लुक एट बी. इन बी एक्स वॉज अ स्टैटिक वेरिएबल, सो this initializes x to 50. तो यहाँ पे मेरे पास x पहले 50 होके सी आउट होगा, प्लस प्लस x होगा और फिर सी आउट हो जाएगा, यानी 51 हो जाएगा. c जो है ये ग्लोबल वेरिएबल x यूज़ कर रहा है. ग्लोबल वेरिएबल मेरे पास क्या था, ग्लोबल वेरिएबल मेरे पास x जो है वो 1 है यहाँ पे. सो दिस इज गोइंग टू राइट 1. उसके बाद क्या हो रहा है, x इज इक्वल टू एक्स इंटू 10. सो x इक्वल टू एक्स इंटू 10 क्या होगा, ये 10 हो जाएगा. और क्योंकि इसका अपना कोई x नहीं है, ये ग्लोबल यूज़ कर रहा है, तो x इक्वल टू जब 10 होगा, इट मीन्स बेसिकली इसको आप 10 कर रहे हैं, ये 10 हो गया. क्योंकि कोई लोकल वर्जन नहीं एक्सेस कर रहा था, ये ग्लोबल वाला कर रहा था, इसके अंदर कोई लोकल x नहीं है, ये इसी को कर रहा है एक्सेस. तो व्हेन इट सेज x इक्वल टू एक्स इंटू 10, basically this x becomes 10. So this is the first pass. The interesting thing now happens when we call a again. A had a local variable x. जब ये x पहली दफ़ा कॉल हुआ था, x क्रिएट होता 25, इंक्रीमेंट हुआ था 26, फंक्शन ख़त्म हुआ, x भी ख़त्म हो गया. तो लिहाजा जब मैं दूसरी दफ़ा कॉल करूँगा a, दोबारा से कोड एग्जीक्यूट होगा, x फिर 25 होगा, प्लस प्लस होगा, फिर आउटपुट हो जाएगा. तो ये काम तो वही करेगा. x इनिशियलाइज होगा 25 से, आउटपुट होगा, इंक्रीमेंट होगा और फिर सी आउट में कर रहा हूँ तो ये मेरे पास 26 आ जाएगा. 25 और 26 उसी तरह जिस तरह पहले आया था. नथिंग विल चेंज. दिस इज व्हाट वी हैव बीन डूइंग सो फार. इट्स अ नॉर्मल ऑटो वेरिएबल. When I call b, since b is static, we said that a static variable retains its value. When I call b for the second time, even though the code says static int x is equal to 50, लेकिन वेरिएबल मेरे पास चूंकि पिछली दफ़ा 51 हो चुका था, तो ये 51 वैल्यू रिटेन रहेगी यहाँ पे. इसका मतलब यह है कि जब मैं b कॉल करूँगा तो ये मुझे आउटपुट देगा 51, उसके बाद प्लस प्लस करेगा, फिर सी आउट कर रहा था, और इस दफ़ा जो है वो 52 मुझे दे देगा. अगर मैं तीसरी दफ़ा बी कॉल करता तो उस वक्त इसमें वैल्यू 52 पड़ी हुई होती, इवन दो कि मैंने इनिशियलाइज जो है वो 50 से किया था। ये इनिशियलाइजेशन सिर्फ एक दफ़ा होती है जब बी पहली दफ़ा कॉल होगा, तो उसके बाद ये वैल्यू अपनी रिटेन रखता है, बेशक फंक्शन ख़त्म भी हो जाए। the third one is C. It's using the global variable. Again it will see out x multiplied by 10, see out again. क्योंकि ग्लोबल वेरिएबल था, ग्लोबल वेरिएबल चेंज हो चुका है, अब x इक्वल टू 1 नहीं था, पिछली दफ़ा की वजह से x इक्वल टू 10 हो चुका है, तो लिहाजा this is going to write 10 multiplied by 10 and then see out again. So 10 multiplied by 10 is 100. This is how it works, and this is basically the difference between the values of x, whether it is an auto integer, whether it is limited to the block, whether it is an extern that is global, and whether it is a static. So this is auto, this is auto. ये दोनों जो हैं ये ऑटो हैं। फ़र्क क्या है? इसका स्कोप पूरे फंक्शन मेन का स्कोप है, इसका स्कोप सिर्फ ब्लॉक का स्कोप है, ये ब्लॉक से बाहर नहीं नज़र आता, हैं दोनों ऑटो। इसका मतलब है जैसे मेन क्रिएट हुआ ये एक्स क्रिएट हो गया, जैसे ब्लॉक क्रिएट हुआ ये वाला एक्स क्रिएट हो गया, ये ब्लॉक ख़त्म होगा ये एक्स ख़त्म हो जाएगा, ये फंक्शन ख़त्म होगा ये वाला एक्स ख़त्म हो जाएगा। दिस इज़ द स्टोरेज क्लास ऑफ दिस इज़ एक्सटर्न, इट्स अ ग्लोबल वेरिएबल। ये तमाम ये फंक्शन शुरू हो ख़त्म हो जो भी हो, ये इंट एक्स रहेगा यहाँ पे जब तक प्रोग्राम ख़त्म नहीं हो जाता। तो और इसकी वैल्यू जो है वो हर जगह एक्सेसिबल है, मेन में भी एक्सेसिबल है और ABC में भी एक्सेसिबल है। तीसरा जो है वो जो बी फंक्शन में था वो था स्टैटिक टाइप का। स्टैटिक वेरिएबल उसका स्कोप जो है वो बी में ही है, बी से बाहर ए और सी में ये वाला एक्स नहीं एक्सेसिबल, मेन में भी एक्सेसिबल नहीं है, इसका स्कोप बी का फंक्शन ही है, लेकिन इसकी टाइप जो है वो स्टैटिक है। व्हाट दिस मीन्स इज़ जब आपने एक दफ़ा बी कॉल किया तो पहली दफ़ा तो ये एक्स इक्वल टू 50 इनिशियलाइज हो गया, जब आपने दोबारा बी कॉल किया तो जो वैल्यू चेंज हो चुकी थी वो रिटेन रही, नए सिरे से एक्स इक्वल टू 50 नहीं हुआ। जबकि ए में एक्स इक्वल टू 25 था, प्लस प्लस किया 26 हुआ, ख़त्म हुआ, एक्स वैल्यू ख़त्म हो गई, दोबारा ए कॉल हुआ, दोबारा इंट एक्स इक्वल टू 25 हो गया। 25 26 25 26 जितनी दफ़ा कॉल करेंगे 25 26 आउटपुट दिया करेगा। जबकि बी में स्टैटिक्स एक्स जो है वो जब भी करेंगे तो वो इंक्रीमेंट यानी किस्म का काउंटर का काम कर रहा है, जितनी दफ़ा आप कॉल करेंगे उतनी दफ़ा इंक्रीमेंट करता रहेगा, तो इट्स वैल्यू विल बी रिटेन्ड। और सी जो है उसके अपना कोई एक्स है ही नहीं, वो तो ग्लोबल में चेंजेस कर रहा है। सो मे बी देयर कैन बी कन्फ्यूजन कि जी वो सिर्फ सी में चेंज होता है, ये 10 यहाँ पे क्यों चेंज हो गया, तो वेरिएबल तो सी में है ही कुछ नहीं एक्स जिसको मैं चेंज करूँ। तो व्हेनेवर आई एम चेंजिंग समथिंग बेसिकली आई एम चेंजिंग द ओरिजिनल द एक्स। कोई इस तरह तो नहीं है कि जी आपके पास सी फंक्शन में कोई वेरिएबल पास हुआ था बाई वैल्यू बाई रेफरेंस, कोई वैल्यू पास नहीं थी, वॉइड फंक्शन था ये, इसमें कोई वैल्यू नहीं पास हुई, सिर्फ जो है वो मेन क्योंकि हर जगह एक्सेसिबल है इसलिए आपको ये एक्स में नज़र आ रहा है। वी सॉ दिस ओवर हेयर, दिस इज़ हाउ इट लुक्स लाइक। सो ये एक मेन फंक्शन था, ये एक मेन फंक्शन था। इसी तरह यहाँ पे एक सी फंक्शन है, उसके अंदर भी ये एक्स एक्सेसिबल है, जिस तरह मेन में एक्सेसिबल था ये भी इसमें एक्सेसिबल, एक सी फंक्शन है। इसी तरह यहाँ पे बी है और इसी तरह यहाँ पे ए है। सो दिस एक्स इज इन द आउटर फ्रेम एक्सेसिबल टू मेन, एक्सेसिबल टू सी, बी एंड ए। इसके पास अपना एक्स है, इसके पास अपना एक्स है, लिहाजा ये लोकल यूज़ किया करेंगे। इसके पास अपना एक्स नहीं है तो लिहाजा ये वाला ग्लोबल वाला यूज़ करेगा। दैट इज़ हाउ इट्स वर्किंग। सो I hope that it is clear with the help of this example what the two or the three types of storage classes do. This is the extern or the global, this is the auto or the local, एंड दिस इज द स्टैटिक। ठीक है, बाकी जो थे म्यूटेबल वो हम पढ़ेंगे नहीं। रजिस्टर इज जस्ट अ रिक्वेस्ट टू द कंपाइलर टू ट्राई टू मेक वेरिएबल इन साइड अ रजिस्टर रदर देन इन द रैम। सो उससे भी हमें कोई ज़्यादा वो नहीं है। तो 5 में से हम यहाँ पे 3 देख रहे हैं, ऑटो, एक्सटर्न और स्टैटिक। नेचुरल क्वेश्चन इज के जी आपने कहा है मुझे कि ये फिगर है, ये x जो है x इक्वल टू 1, ये यहाँ पे भी एक्सेस है, ये मेन में भी एक्सेस है। मेन में मैं क्योंकि मैंने एक नया x बना लिया तो मेन में ये वाला x यूज़ हो रहा है। अगर मेन से मैं ये x एक्सेस करना चाहूँ तो क्या हो सकता है, इवन दो कि मैंने यहाँ पे एक लोकल वेरिएबल बना दिया, क्या मैं ग्लोबल एक्सेस कर सकता हूँ? तो द आंसर इज़ यस, आप कर सकते हैं। और the way to do it is using the unary scope resolution operator double colon. So if you write a double colon, you will be accessing the global variable even if there is a local variable. Let's look at an example. यहाँ पे मेरे पास वही hash include iostream using namespace यहाँ पे आ जाएगा। यहाँ पे मैं करता हूँ int x is equal to 10, then I have int main में again int x is equal to 5, cout x. What will be cout? Because main has a local version of x, so the value 5 will be cout. अगर मैं 10 cout करना चाहता हूँ तो what I will do is cout colon x. अब इवन दो कि ये x है, जब मैंने ये यूनरी स्कोप रेजोल्यूशन ऑपरेटर लगा दिया, इट मीन्स दिस विल बी एक्सेस्ड एंड अब मुझे आउटपुट जो आएगा वो 10 आएगा। So in this way you can access the global variable even if a local variable with the same name exists. Not needed if the names are different. अगर नाम different होते फिर ज़रूरत नहीं थी। What this means is कि अगर मेरे पास होता int x is equal to 10 और यहाँ पे मेरे पास int main, अब मैं x नहीं यूज़ कर रहा, मैं y is equal to 5 कर रहा हूँ, तो cout y ये क्या होगा 5। अगर मुझे ये x करना है cout तो मैं x ही लिखूंगा, कोलन के साथ नहीं लिखूंगा क्योंकि कोई कन्फ्यूजन नहीं है, मेन के अंदर कोई x नहीं है। जब मैं cout x करूंगा तो ये वाला ही होगा, तो ये 10 आ जाएगा। Return 0 and exit. So this is needed when there is a local and a global variable with the same name. That is when you need to resolve the scope of a variable. If they were different, you don't need the scope resolution operator. It means that something that is global is automatically accessible in the local. So using the figure that I am so fond of using, I have something like this. So here I had x is equal to 10. In the first case in my main I had x is equal to 5. So यहाँ पे अगर मैं cout x करूँगा तो उसको ये वाला उठाना है। अगर मैं चाहता हूँ कि इससे बाहर जाए तो फिर मुझे स्कोप रेजोल्यूशन करना पड़ेगा। जबकि सेकेंड केस में मेरे पास x is equal to 10 था और यहाँ पे मेरे पास y is equal to 5 था। जब मैं cout x करता हूँ तो यहाँ पे इसको x नहीं मिला तो ऑटोमेटिकली अपने से ऊपर जाके देखेगा x अवेलेबल है तो उसको यूज़ कर लेगा। You don't have to use any scope resolution operator. So I hope that is clear. We'll discuss further in the next interactive class if you have any questions, or maybe we'll look at another example. So I hope it's clear. If there are any questions, you can ask either on using the post on MS Team or during the next interactive session. So with that we will stop.